We present Style City, large-scale 3D urban scene stylization, a vision and text-driven texture stylization system for large-scale urban scenes. We target to stylize a 3D large urban scene with foreground 3D assets and stylize the sky background in a harmonic way. So, how could we stylize a large-scale virtual urban scene? In a conventional way, we need to recruit an artist to model multiple 3D assets, and design and set up all the textures and materials. And finally, we also need to set up different lightings for the final rendering. The whole process is kind of tedious and really takes time. Therefore, we want to automate the process of stylization of a large urban reconstruction scene. However, 3D urban scene style transfer is challenging. The urban scene is of large scale. The large scene contains complicated semantics such as buildings, roads, and trees. Additionally, we're concerned about the sky with a harmonious style. To this end, we propose the first text and image-driven automatic urban scene texture stylization system, Style City. Our proposed Style City framework can automatically stylize the texture meshes of large-scale urban scenes and generate harmonic omnidirectional sky backgrounds in a controllable manner with the input text and image references. Here shows the framework. Taking the input texture mesh, style image and text references, and the preprocessed segmentations, we augment training wheels into different scales and render images and segmentation maps. Meanwhile, synthesize a style-aligned omnidirectional sky background for the final rendering. We then select a scale-adapted style reference for the texture style supervision. With the global and local style losses and content losses, Style City can optimize a compact neural texture film in a semantics-aware fashion progressively. After the texture optimization, we can compose the baked texture from the neural texture film for the stylized model, which enables real-time rendering. We end-to-end optimize the texture by multiple training wheels using different content and style losses. Next, I will highlight some details designed for 3D urban scene style transfer. To resolve the problem of large texture, we select a compact UV-based neural texture film, which reduces the memory consumption during optimization. Most existing works tend to uniformly plan training wheels with fixed camera intrinsics, which is not applicable for a large-scale scene. Therefore, we propose a multi-scale progressive optimization strategy. First, we preset some preset training wheels with several viewing centers of the scene. Then, during optimization at each level, we progressively reduce camera field of view and randomly sample novel training wheels based on pivot wheels, such that the high-fidelity content features can be well learned progressively. To resolve the complex semantics problem, we directly use pre-trained 2D semantic segmentation model to segment urban scenarios and supervise semantic style features for each class region. Since we render different scale training wheels, to keep the style consistent at scales, we propose to select scale-adapted style image for supervision. We utilize latent feature self-similarity as the image structure representation and select the style patch with the closest structure distance to optimize the current training wheel. Finally, to enhance the atmosphere, we automate the style-aligned sky synthesis. Specifically, we propose the omnidirectional latent features sampling strategy and utilize multi-window joint diffusion technique with a perceptual loss. Our Style City enables users to personalize their 3D mesh textures by selecting different style references. For example, the system can imitate time of day effects, Our system also supports non-photorealistic stylization and 2D to 3D editing. Please refer to our paper for more details.